This is the kind of question that sounds fun until you actually do the math. Spoiler, we're all going to die. But let's figure out exactly how we're going to die. First, let's establish what we're dealing with. Scientists estimate there are approximately 20 quadrillion ants on Earth. That's 20 quadrillion ants. If you tried to count them at 1 ant per second, it would take you 634 million years. For every single human, there are about 2.5 million ants. Currently, this isn't a problem because ants are tiny. A typical ant weighs about 1 to 2 milligrams. But what if they were dog-sized? Let's say our ants are now the size of a medium dog, about 15 kilograms each. Here's where it gets terrifying. Ants can lift 50 times their body weight. A 15-kilogram ant could theoretically lift 750 kilograms. That's a motorcycle, or a cow, or you and 4 of your friends. And they wouldn't lift you to help you move apartments. Let's talk about biomass. Currently, all the ants on Earth weigh approximately 12 billion kilograms combined. That's about 20% of total human biomass. But if every ant became dog-sized, 20 quadrillion ants times 15 kilograms each equals 300 quadrillion kilograms. That's 300 quadrillion kilograms. For comparison, all humans weigh 420 billion kilograms. All livestock weigh 550 billion kilograms. All wild mammals weigh 22 billion kilograms. Dog-sized ants would weigh 300 quadrillion kilograms. The ants would outweigh all other land animals by a factor of about 300,000. Ants need to eat a lot. A normal ant eats about 1 to 2% of its body weight per day. A dog-sized ant would need approximately 150 to 300 grams of food daily. 20 quadrillion ants times 200 grams per day equals 4 quadrillion kilograms of food per day. The total biomass of all plants on Earth is about 450 billion tons. At this consumption rate, the ants would eat all vegetation on Earth in approximately 3 months. But wait, ants aren't just herbivores. Many ant species are carnivorous. Army ants, in particular, don't build permanent nests. They march in colonies of up to 20 million, eating everything in their path. Now imagine 20 million dog-sized army ants marching through your city. Each one can bite through bone, run at highway speeds, scaled up, coordinate attacks with millions of others, keep fighting even when severely injured. We are outnumbered 740 million to 1. Let's say humanity unites against the ant threat. What are our options? Option 1, guns. Ants have exoskeletons. A scaled-up exoskeleton would be like natural armor. Small arms fire would probably be ineffective. You'd need armor-piercing rounds at minimum. Also, there are 20 quadrillion of them. We don't have that many bullets. Option 2, pesticides. Current pesticides work by being absorbed through the ant's respiratory system or exoskeleton. Scaled up, you'd need massive quantities, like drain the oceans and replace them with raid quantities. Option 3, fire. Fire could work. Exoskeletons are flammable, but you'd need to burn approximately all of Earth multiple times. Option 4, nuclear weapons. We have about 13,000 nuclear warheads. That's 1 nuke for every 1.5 trillion ants. The ants would barely notice. Here's how humanity ends. Day 1. Ants wake up dog-sized. Mass panic. Infrastructure destroyed immediately. Ants don't understand what happened either, but they're hungry. Days 2 to 7. Agriculture collapses globally. Military responses fail. Major cities overrun. Humanity retreats to defensible positions. Islands, mountains. Bad news. Many ant species can swim. Some can form rafts out of their own bodies. Days 8 to 30. Food supplies exhausted. Ants have eaten most other animals. Human population drops to approximately 100 million, hiding. Days 30 to 90. Ants consume remaining vegetation. Ecosystem completely collapses. Ants begin starving too. Ironic. Human population, approximately 10 million. But here's the thing. Giant ants couldn't actually exist. Insects don't have lungs. They breathe through tiny tubes called tracheae that deliver oxygen directly to their cells. This system only works at small scales. A dog-sized ant would suffocate almost immediately. The oxygen simply couldn't reach reach its internal organs fast enough. Additionally, the square cube law means their legs couldn't support their body weight. Their exoskeleton would crack. Their internal organs would be crushed by their own mass. If ants became dog-sized, they would die within minutes. So the good news is, physics won't let this happen. The bad news is, if physics did allow it, we'd all be dead in about 90 days. The next time you see an ant in your kitchen, remember two things. It can't become giant because of physics. If it could, you'd be dead. Sleep well. If you like this video, please subscribe my channels for more wild facts that'll blow your mind.